This is problem number 1 from section 7.3. They ask you to solve the algebraic equation for x, then solve the trigonometric equation for 0 degrees less than or equal to theta less than 360 degrees. Now all this means 0 less than or equal to theta less than 360 is they want you to solve this equation here, this trig equation, for the solutions that are in one revolution of the unit circle. So 0 to 360. So they only want you to give the answers to this problem between 0 and 360 degrees. They don't want you to go around once and then around twice and then 3 times, because really you can go an infinite amount of times around the circle and get different degrees as answers, right? Because we can get 30 degrees and we can get the coterminal angle 390 if you add 360 to 30, and then you can keep going and going and going on forever. So they're saying just between 0 and 360 to make sure that you essentially don't have an infinite amount of solutions. Now part A is, this is algebra 1 material here. We add 1 across, we get 2x equals 1. We divide by 2, we get x equals 1/2. Now they're showing you that because they want you to understand that when you solve a trig equation, in this case the cosine theta is like x. So you could even write that this is kind of like x, cosine theta. So we just solve the equation the same way until we get down to cosine theta being isolated. So we're going to add 1, so we get 2 cosine theta equals 1. Divide by 2 and we get cosine theta equals 1/2. Now what's different about these problems than about a normal algebraic problem is now at this very last step we're essentially going to find what theta is, what angle for the cosine function gives you 1/2. Well, if we look at our unit circle, you'll see that, and remember cosine will deal with the x values. So we'll see that x values are here. Oh, x value of 1/2. Well, that's 60 degrees or pi over 3. So we can write that one of our solutions is 60 degrees. So theta, write that out right below here. Theta, actually let's write it here. Theta equals 60 degrees. And then there might be another one on here. Let's look. So 1/2. Nope. And remember, we're looking at the x values. I was looking in the wrong spot. So no, nope. Up 1/2 right here for cosine. So that's 300 degrees. So we have 300 degrees. Now this should actually make some sense to you. If I go 60 degrees this direction, I get cosine theta to be 1/2. If I go 60 degrees negatively, right, the other direction, I also get cosine to be 1/2 because we know cosine is positive in quadrants 1 and 4. And so our solutions are 60 degrees and 300 degrees. Now the only reason I say it's 60 degrees and 300 degrees is in the My Math Lab they ask you for degrees in, they ask you for the answer in degrees. If they ask you for the answer in radians, you'd say pi over 3 and 5 pi over 3. That's essentially the answer to this trigonometric equation. As you can see, it's very similar to how we solve it algebraically. The last step is we just look on the unit circle to find out when cosine theta, what degree theta needs to be in order for cosine of that degree to give me 1/2.